Hi, my name is Sarthak, and this is the first lecture in our econometric series. And the first lecture that we're going to be discussing will be about introduction to data types. Now, the goal of this lecture is pretty simple, and it is to understand what different data types exist throughout the process of econometric analysis and what can be used in our regressions and everything that we do as a part of this entire course. Right, now let's get on to the meat of the data. There are four core major data types. One, cross-sectional. Number two, time series. Number three, pooled cross-sectional. And number four, panel and longitudinal data. Each of these data types have their own intents and purposes. This particular slide is a very easy cheat sheet, and perhaps I'll agree that it's oversimplified, but it's an oversimplified version of a wide variety of data types. Starting with cross-sectional. Over here, you're tracking multiple metrics for a single time period. Time series, the opposite. You're tracking one metric or more as well at times, however, for multiple time periods. Pooled cross-sectional is you take two cross-sectional datas, put them together in such a way that the items that you're tracking in cross sections do not overlap and you're able to track for more than one period. Finally, the king of all data types, panel slash longitudinal data. As you may imagine, panel means a wide variety of metrics, but at the same time, over a large period of time, tracking multiple varieties of things. So this way, you get a panel data set. In the next slide, what I've done is that I've differentiated it further by using a table. Perfect. So now, as you might have imagined, that understanding all these different types might be complicated to remember, but it's very key to note that this is the fundamental of all the analysis that we'll be doing as a part of this course. So what I've done here is that I've differentiated them across four different metrics. One is items tracked, periods tracked, are they random or not, and then an example for each of them. Re-referencing cross-sectional. As I said that we're tracking multiple items over a given period of time, and each of those items that are tracked are for random subjects. This could be college admission statistics. Now think about it. For college admission statistics, you've got um, the name of the student, which comes in the x-axis or the first column, let's say. You've got multiple metrics for that student. You've got your SAT score, you've got your high school GPA, you've got a rating out of 5 regarding how good or bad are they in terms of their extracurriculars, and so on and so forth. But that's for a specific academic admission cycle. That is what is cross-sectional data. Then you've got time series. Imagine tracking something over time. So let's say you and your parents track your grades from first grade till your in your master's program. That entire process of tracking that one final grade point or multiple is essentially what's time series, and hence we see that in the form of GDP over time. Pooled cross-sectional, and I briefly mentioned this last time, it's a combination of two cross-sectional data coming together. But remember that the key aspect of differentiation is that the subjects that are tracked are random, and it is very unlikely that the two subjects will overlap across two cross-sectional data sets. For example, we were studying the crime statistics for 2013 and 2015 and 2018 in Chicago. You've got different sets of households across different areas, and we're trying to take an interpretation of what do you feel about the crime statistics in Chicago from different families. And as a part of this pooled cross section, because the basis of cross sectional data is that the data is randomly arranged or the subjects are randomly picked. Similarly, it's very unlikely. Think about it. Is it likely that you are going to be selected in a lottery twice? Chances are yes, but it's highly unlikely. And similarly, for pooled cross section, you take a random set of participants, combine two cross-sectional data sets from one point and another, and then bring them together for further analysis. And this is used for something that's called difference in differences and synthetic analysis, and we'll talk about this later. It's probably one of my most favorite topics. Then you've got panel and longitudinal data. Now, this is the best kind of data set you could ever ask for. This is very difficult to find. Um, it occurs regularly, but in terms of when you're looking for the analysis, it's probably the most difficult one to find. But it's essentially tracking a lot of subjects, a lot of metrics over a long period of time. So this could be anything like economic indicators over time, and that way you're able to get a succinct, complete analysis. Perfect. Now, what I'm going to do is going to deep dive on each one of them so that we are able to make sure that we have a complete understanding of it. Firstly, talking about cross-sectional again, over here you can see that I've attached a sample, a very simple made-up data set, which essentially has data for 2010 for multiple households, households 1, 2, 3, 9, and 10, across different areas and different income levels, different employment statistic, and whether there's a policy change or not. This way, we're tracking, as you can see, so we're tracking multiple households for a given period for multiple metric points. All these household data collection is fairly random. And in order to ascertain that, we need to go further into collection techniques, but that's for another time. Now we have time series. Time series, as I talked about, is tracking one or more metrics over a long period of time. Over here towards the right, I've mentioned the example of real GDP growth of China over time. So it's 2004 to 2010. It mentions the real GDP growth, which is a metric that we're tracking. I've also mentioned the code that I've used in order to track this particular thing. Um, Again, this is the real code that I've used for Stata, and this is a good starting point to tell you that I'll be using Stata and Excel a lot, and I believe that this is the foundation of our econometric analysis, and there are multiple other tools used. However, we're going to be using Stata and Excel primarily. Recalling the slide that we talked about a slide and a half ago, or 2 slides ago, where we talked about cross-sectional data, here is where the two cross-sectional data come together. So as I had mentioned, we're using independent random samples from two or more different periods. Here is exactly what I mean. We've got 2010 and 2015 as two different year marks. You've got different households. They might be organized in a very numerical way, but they're assuming that these are very random households from different locations, and they provide different statistics or different metrics are being tracked over time. And as a result, you're able to see whether on random is there an effect of policy change or not in terms of the metrics we're trying to track. And that's how useful pooled cross-sectional data set is. And lastly, you've got panel and longitudinal data. As I said, this is the king, or this is the epitome of all data types. And as you can see on your screen over here, using a data code that I've ran, I'm just trying to understand the the metrics associated with multiple flight routes over multiple years. So in this particular screenshot, you can see that it's only 2006, I believe, 2016, but there are multiple more years being tracked as part of this data set. So it's essentially tracking multiple subject items or individuals or objects for multiple perform metrics over a long period of time. So this becomes a really large data. And this brings us to the end of this lecture. It's this Throughout this lecture we learned about 4 core data types. Please do revisit the first slide that I showed. That provides a very good insight into what has been covered and what key definitions are there to remember. Please do remember these examples as well and try to search for these examples over the internet. Play around with the data. You'll learn the most through that way. Thank you.